Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the rotate image problem. Given an n by n matrix that supposedly represents an image, we want to rotate it by 90 degrees. So the 7, 4, 1 that run up this side are going to run across 7, 4, 1. The 3, 6, 9 that run down, they're going to run backwards 3, 6, 9, so on and so forth. Now, how to actually do this, I'm not sure. There's very obviously a somewhat recursive solution here of once I've done this outer ring, I just do it again for the matrix on the inside, but the problem is specifying effectively how to do the indexing in that inner ring. And even then that still leaves the problem of how do I actually do that rotation of the outer ring, but yeah, because it's not something like a transposition. This transposition would have the 1, 2, 3 run down here, but we actually want it going over there. Yeah, no, it's not a transposition, and I don't think it can be got to by a transposition either. So let's do this as an actual rotate. Self.rotate helper matrix, and then what I want to do is I want to start at 0 and go until len matrix. Rotate helper, and then that takes self matrix. In fact, to avoid the temptation to mutate things, to not mutate things, I might actually do it this way. Self start end. So the idea is if end minus start is less than or equal to 1. So the idea is if we have a 1 by 1 matrix or a 0 by 0 matrix, we are done. And then what I want to do is do something, and then finally I want to do self.rotate helper with start plus 1 and minus 1. So broadly thinking is if I'm doing a 1 by 1 or 0 by 0 matrix, there's nothing to do. Otherwise, I want to do the outer ring, and then I want to, rather than going from 0 to ending at 3, using the minus 1 thing, then I want to actually start at 1 in and down and go across until 0 and 2, which so it was 3, which now goes to 2, which means I want to stop before I get here, which is just rotating this little inner one. So now we're left with this rotate ring business. I might do, what do I want to do? One thing, sorry, I'm being very quiet here. I'm thinking, would it be good to generate the indices that I need to do as a sequence and say, well, I need to do this one, 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 and then loop back to this one and say, well, I want to move this No, I want to move it forward by, well, no, that could work. So I do all of the indices and then repeat the first end minus start of them. So I do 0, 0, 0, 1, 0, 2, 1, 2, 2, 2, 1, 2, 0, 2, 0, 1, and then I would repeat these ones again just because for bookkeeping purposes it'll be easier. And then what I want to do is I basically want to move these along by whatever the width of this thing is. Here I want to go 1, 2 further along, and if these are sort of all been linearized, that tells me where I want to put it. The problem is I'm going to clobber things. If I want to put this here, I'm going to overwrite this thing. Maybe when I create these indices, I also want to keep no, okay, we do it in 2 passes. Do we do it in 2 passes? So the problem is, if I only need to remember a few things, up to n things. That's the problem. I need to kind of remember up to n things. Because I'm going to clobber this 3 and this 6 before I get to the 3, which I then need to put down there. Well, one thing I could do is I generate those indices and then I keep a queue that I've preloaded with a couple of dummy values, and then I just overshoot my loop. Self.make indices start end. Queue is collections.deck, and I want to preload this with 0 times end minus start. I think I can get away with a -1 there. Here I'm going to write the first thing in the queue, which is a dummy. Here I'm going to write the second thing in the queue, which is a dummy, and now I want to go up to, I need this -1 here. For x, y in, oops. I don't need to make that self. Oof, gosh. Indices. What I want to do is I want to do q.append self.matrix x, y. Self.matrix x, y is q.pop left. So I save the 1 away in the queue, and then I read whatever's on the queue, which in this case is going to be a 0, but that's all right because the indices I'm going to generate are going to go all the way back around to here. I'm going to over-generate my indices. I think that's fine. The other option is I preload my queue with these values. See, that's an idea. Indices taking from negative end minus start minus 1 through to the end. What I want to do is I want to take self.matrix x, y, 4x, y in. So what this does, rather than filling it with dummy values, I just take the last two, in this case, indices of it. So if we start at 0 and 3 is my length, I'm going to do 3 minus 0 is 3, minus 1 is 2, negative 2. So I'm going to take the last two values from my indices list. I'm going to see what was written in those places, and it should be these two. And what I want to do is I want to make those the things that are on my queue. The 7 and the 4 go onto the queue, so when I start working my way through the indices list, they're going to come off the queue. Okay. It's a wee bit complicated, but I think it works. So now we're just left to try and do make indices start end. Result is empty list for let's go for x in range start end. Result.append x start. So this is going to be the top row. For y in range start plus 1 and result.append end minus 1 y. Now we're working down this side for x in range end minus 1 start, in fact it's end minus 2 start minus 1 negative 1. So I'm counting backwards. I want to do result.append x end minus 1 for y in range end minus 2 start negative 1 result.append start y return result. That one's a bit messy. The idea is we're going to go across, down, back, up. Those three there. That gives me all of the indices. Does that work? I might put in some diagnostic print statements to begin with because I'm not 100% confident in this. I want to see what indices I'm getting at each layer. And then I want to print the matrix after doing that transformation. And what I might do is just label these before and after. Let's see, first off, syntax check. Missing a self. I don't think I can learn any more from that. Okay. I got 0, 0. Oh crap, I'm meant to be going across for the Y's first. I'm an idiot. I got these completely wrong. Because I'm going, this is my Y. which is slightly confusing. I'm going to call that X. Now I'm going to call this column. For row, Jesus. For column, row, whoops, click. Right, let's see if that helps matters. Looks like it helped a lot. Yeah, 0, 0, 0, 1, 0, 2, 1, 2, 2, 2, 2, 1, 2, 0, 1, 0. And then obviously we preloaded this correctly so that when we walk around, we're going to correctly fill up all the different things. Let's use both example test cases just to see if we've missed anything here. That looks good. Let's do our own special tests. And whoops, we're told that this is at least a certain size. Yep, that looks good. Let's get rid of these diagnostics. This is actually not a bad question. I'm quite impressed with myself, actually. So it's this make indices thing, which is a little bit fiddly, and this use of a queue. I think this is a neat use of a queue here, because it lets us do this sort of buffered memory space. The queue is never going to get terribly large because every time we push something on, we pop something off again, so it's never going to grow infinitely or anything. So, nice wee solution. You could do this with a ring buffer. Excellent. Made it to the end. We're, I imagine, pretty middle of the pack on both of these. I'm happy with that. I'm very happy with that. Thank you very much for watching. I hope you enjoyed this too. Do remember to like, comment, subscribe, all of that good stuff. And I hope you have a wonderful day. I will see you next time. Bye. That was a bit of a rough ending.